Okay, this is Algebra 1D 12.6 Permutations and Combinations video lesson. The object is to find permutations and combinations. So permutations and combinations involve counting different ways of ordering things and grouping things. So that's what we're going to start with here. So here's an example. Say you're trying to figure out the possible orders that you could watch movies. 3 different movies. One's a comedy, one's a drama, and one's an action film. So one way to figure out how many different ways to watch them or possible orders to watch them is to make a tree diagram like this. So if comedy is first, then either drama could be second or action could be second. If drama is second, then action is third. If action is second, then drama is third. So those are 2 possibilities, right? And then you just go through, well, what if drama was first? Then action could be second or comedy could be second. And then you have those examples and then here and so on. So then and then you just count them 1, 2, 3, 4, 5, 6. So you have 6 different orders that these 3 movies can be watched in. Making a tree diagram isn't always realistic, right? If you had 17 movies that you wanted to watch in what order, right? You're not going to write down all the different orders. So there is a mathematical way about figuring this out. And the first way to figure this out is if one event does not affect the result of a second event. So if you watch a comedy first, it has no effect on if you watch a drama or action next. And so those are called independent events. So when the events are independent, then you can find the number of outcomes using this multiplication counting principle, which is pretty easy to use. If there are m ways to make a first selection and n ways to make a second selection, there are m times n ways to make 2 selections. So for the example, if you have 5 shirts and 8 pairs of shorts, what are the possible outfits you can make with just a shirt and shorts? Well, you have 5 choices for the shirts, 8 choices for the shorts, so 5 times 8 is 40. You don't have to make a big whole tree. Isn't that exciting? So here's an example. Here's a picture of a shopping mall. In this diagram, how many ways are there to get from the first floor to the 3rd floor using only escalators? Well, if you're on the first floor, there are 2 escalators you have to choose from. So 2 choices. Once you're on the 2nd floor, you then have 3 choices. And then you just multiply them together. 2 times 3 is 6. So you have 6 different ways to get to the 3rd floor from the first floor using only escalators in this example. Okay, so try this next example on your own. A pizza shop offers 8 vegetable toppings and 6 meat toppings. How many different pizzas can you order with 1 meat topping and 1 vegetable topping? Press pause if you need to. See if you can figure out the answer and then check back for the solution. Okay, I'm not even pressing pause because we can talk through this, right? You have vegetable toppings and meat toppings. You have 8 vegetable toppings, you have 6 meat toppings. 6 times 8 is 48. So you have 48 different pizzas you can make, if each one has a vegetable and a meat. Isn't that nice? Okay, so now we've moved on to defining permutation. So a permutation is an arrangement of objects in a specific order. Okay, so an example would be if we have 3 different letters, A, B, and C. The possible permutations without repeating any letters, so you only have 1 A, you have 1 B, and 1 C, and order matters. Right, if A is first, you have B and then C. A is first and you have C and B. B is first. This is kind of like a tree diagram. So you have 1, 2, 3, 4, 5, 6 different ways of doing that. Okay, so a band has 7 new songs to perform in a concert. In how many different orders can they perform the new songs? Okay, so we're going to use some, the songs being played don't have anything to do with the song before it or after it, so they're independent. So we can use the multiplication counting principle. So the first song, the band has 7 choices, right? Then the second song, you've already played 1, so you have 6 left. You have 6 choices for the second song. For the third song, you have 5 left. Then so on, 3, 2, and then once you get to the last song, there's only 1 song left to choose from. So in order to get the answer here, you just have to multiply 7 times 6 times 5 times 4 times 3 times 2 times 1, and that is 5,040 ways. There are 5,040 different ways they can play 7 songs in a concert. Isn't that exciting? And then this, I'm actually going to talk about this in the next page, but when you have a number and you're multiplying it by the next number below it, one less than it, all the way down to 1, this is called factorial. This could be actually rewritten 7 factorial, and it's an exclamation point. And some calculators have it, which is really nice, and you may see them. But this is called 7 factorial. Okay, so moving on to one example for you to do on your own. A swimming pool has 8 lanes, and how many ways can 8 swimmers be assigned for the race? Assigned lane, sorry, for the race. So press pause, try this one on your own, and then check back for the solution. Okay, see, I didn't write the solution. I'm just going to go through with you. Right, for the first swimmer, there are 8 choices. The second swimmer, one has been gone, so there's 7 left. 6, 5, 4, 3, 2, and in the last lane, there's only 1 person left. So this is actually 8 factorial, which is my calculator actually has a factorial button, which is nice. 3, 2, 0. There are 40,320 different ways that 8 swimmers can be assigned a lane for a race. Isn't that insane? Okay, moving on. Okay, so here's where the book describes factorials. I could not wait. Right, and this is saying the same thing. This short way to write problem 2 is 7 factorial. This reads 7 factorial. 7 exclamation point means 7 factorial. And this works for any positive integer. Integer is like a counting number, or positive integer would be a whole number, or a natural number, we say, just counting numbers. And they like 1, 2, 3, and so on. The expression n factorial is written as n exclamation point, and it's a product of these integers from n all the way down to 1. And then just a side note, 0 factorial is 1. So you can kind of think of that as how many ways can you arrange nothing? 1 way, nothing. And then so here's some other examples. 4 factorial is 4 times 3 times 2 times 1. 8 factorial is this. I did say in the last page that my calculator has a factorial button. If you are using Desmos, you can use just the exclamation point as factorial. So in Desmos, if you just write 8 factorial, it will give you this number. Or sorry, 8 exclamation point, it will just give you this number. So you have access to that as well if you do not have a calculator with factorial on it. So you can use factorials to write a formula for the number of permutations of n objects arranged R at a time. So in our examples, we had how many different ways are there to order 7 songs? That's 7, that would be 7 objects, 7 at a time. And then how many, 8 swimmers in 8 lanes, that's 8 objects, 8 at a time. And so that's why it was just factorial. But if we say we had 5 swimmers in 8 lanes, how many different ways could you arrange those 5 swimmers in those 8 lanes? And that's when you would use this permutation notation. This would be, you have 8 lanes, 8 objects, and you arrange them 5 at a time. So here, the formula for that, and the notation is this little n in front of this big P and this little r on the other side. So it's like NPR. And this means the number of permutations of n objects arranged R at a time is n factorial divided by whatever the difference is, n minus R, and then that number factorial. So if you were, in this example, if you had 8 things, say you had 8 people in a class, and 2 of them, you needed a president and a vice president of the club, say it was a club or something. How many different ways do you have of order of getting a president and a vice president? Would be 8 factorial divided by 8 minus 2, which would be 6 factorial. And if you did all of that math, you would get 56. Here's a quick little shortcut to see. You can actually do these by hand when they're close, because you can see once you get to 6, all the numbers here cancel to 1. These all go to 1, and so you're only left with 8 times 7, which is 56. So you can do some of these by hand. This first example, not so much. Well, you can. Well, no, not by hand, but you still need your calculator, but you wouldn't need the factorial button. So band has 7 new songs and wants to put 5 of them on a demo CD. How many arrangements of 5 songs are possible? So you have 7 objects, and you want 5 different arrangement of 5 songs. So this would be 7 factorial divided by 7 minus 5 factorial. 7 minus 5 is 2. So this is 7 factorial divided by 2 factorial. So 7 times 6 times 5 times 4 times 3 times 2 times 1. And then this is just 2 times 1. So the 2's cancel and the 1's cancel, but then you still have to do this with a calculator. So that's not an easy one to do. But if you put in Desmos 7 exclamation point divided by 2 exclamation point, you can easily see that this is 2,520 different ways, or demos arrangements. Okay, so try this next one on your own. There are 6 students in the classroom with 8 desks. How many possible seating arrangements are there? Press pause, try this on your own, and check back for the solution. Try to do this one by hand. This one's easy enough to do by hand. Oh, no, it's not. Never mind. Sorry. I was thinking it was this one. No. You can try this with Desmos. Okay, hopefully you got 20,160 different ways or arrangements. I just always write ways. I think that is fine. And if you wrote out the factorials, only the 2 and the 1 cancel, right? Because the difference here is 2. And so you'd have to do 8 times 7 times 6 times 5 times 4 times 3, which is 20,160. Or just put this into Desmos. 8 exclamation point divided by 2 exclamation point. Okay, moving on. Combinations. So combinations are a selection of objects without regard to order. So if you're selecting 2 side dishes from a list of 5, or the order, in the order that you choose the side dishes doesn't matter. So like in that example where I said, how many different ways, here is the notation for a combination. Instead of a P, it's a C, and it's N objects chosen R at a time, so it's still the same N and R, it's just the order doesn't matter. And so that formula is N factorial divided by R factorial times N minus R factorial. So you have to do the N minus R factorial and then times it by the R factorial and then divide it by N factorial. So it's a little bit more complicated. But going back to our example where, say we have 8 kids in a club and you need 2 to be president and vice president. If one is president and one's vice president, that's a different arrangement than those same 2 people being president and vice president. But with a combination, order doesn't matter. So this would be more like if you had a club and you needed 2 people to be the leaders. Didn't matter which one was president or vice president, right? You just have to pick 2 from 8. So this would be 8 factorial divided by 2 factorial times 8 minus 2 factorial. Which is 8 factorial divided by 2 factorial times 6 factorial. And then you can see here that you're going to have less combinations, right? This 6, this 5, this 4, this 3, this 2, this 1 all cancel. This 2 can cancel with the 8 and leave 4. And this 1 is just 1, so 7 times 4 is 28. So you could do that one by hand. So you only have 28 different choices if the order doesn't matter. And so that's what the key for combination is, that without regard to order. This is just order doesn't matter. Okay, so problem 4 says there are 15 toddlers in a preschool class. How many different 8 student groups can be chosen to play outside? So this is 15C8. And so this is going to be 15 factorial divided by 8 factorial. And then the difference between the two, 15 minus 8 factorial. So this is 15 factorial over 8 factorial over 7 factorial. So here we have 15 times 14 times 13 times 12. Nobody wants to write this all out. That's why Desmos is good. I don't even know why I'm doing it right now. Sorry. We can actually, let's just use this as an example. I forgot about this. This can just be written, right? You can stop this 8 here, 8, 7, 6, 5, 4. This is just 8 factorial. So you can just write that as 8 factorial. And then all of these are going to cancel with all of these. You still have your 7 factorial with the 6 times 5 times 4 times 3 times 2 times 1. And then this, you can kind of do that. 7 goes into 14 2 times. 6 goes into 12 2 times. 5 goes into 10 2 times. 4 knocks out these 2 2s. 3 goes into 9 3 times. 2 can knock out this 2. So then you have 15 times 13 times 11. Still need a calculator. So that would be 2,145. Oh, I did something wrong. Well, then let's see. This is why we don't want to do it by hand. So let's just go in Desmos and put 15 exclamation point Then I'm going to hit the divide button, and it's going to put things on the bottom. I'm going to do 8 exclamation point and then 7 exclamation point. And I get, oh, that's because I forgot this 3. So this is times 3. There we go, 6435, which is what I got on Desmos, which is this answer here. Great. Hopefully I didn't confuse you too much. You can look at your book and look at videos on factorials if you're confused. Or email me with any questions. So here, try this one. In how many different ways can you choose 3 types of flowers for a bouquet from a selection of 15 types of flowers? Again, in this example, order doesn't matter, so you're going to use combination and then use this combination formula. Try to do it by hand if you can, and then if not, put it into Desmos, or do both and check your answers. I think that's a good way to get used to factorials, how they work. Press pause and then check back for your solution. Okay, hopefully you got 455. If you did it by hand, you could see that, see how I did it here, 15, 14, 13, as soon as I got to the biggest one on the bottom. So 12 was the biggest one on the bottom. So as I was breaking this factorial out, 15, 14, 13, I stopped at 12 and made that a 12 factorial instead of writing all the rest out. Because I knew that this one was just going to cancel, all of these numbers were going to cancel with that. So I stopped at 12 factorial, I canceled those. I was just left with a 3 and a 2. The 3 went into the 15 5 times, the 2 went into the 14 7 times. So this ended up just being in the calculator 5 times 7 times 13, which I got 455. And then I checked it on Desmos. I put just this right into Desmos like that. And I got 455 as well to check and make sure I got it right. So the answer is 455 ways. Wasn't that fun? Side note, Desmos, if you're in Desmos, you can click the Functions button, and under Stats menu, you can see the there is actually the NCR thing or the NPR thing. So if you click, let's click NCR and put in 15, 3. I don't know if that's how it works. Yeah. So it actually, it comes up when you click this button, it comes up like this with the parentheses. And so it's not actually clear how to do it. But what I did was I guessed and I got it right. I put my first number for N, which in this case was 15. And then I just put a comma. And then I put the number for R, 3. And then I hit enter. And then or actually just showed up 455. So that's how you would do it in Desmos. And the same with the NPR, if you wanted to do that. You don't have to memorize the formula for that. But it's good to know that formula. It does come up if you're going to do any kind of stats in college or later in high school. This stuff is just really useful and comes up a lot. Okay, there is your practice. Enjoy.